Welcome to this Scicom machine learning tool tutorial. In this session, we'll explore how to use multi-layer perceptron classifier to solve a multi-class, multi-variable classification problem. Our dataset is the global coffee health dataset, which records coffee consumption, life habits, and health outcomes across 20 countries. The goal is to predict whether an individual has health issues based on daily habits, stress levels, and demographical information. Before training the MLP, we must pre-process the global coffee health dataset. The dataset includes over 1,000 rows and 15 columns of health and lifestyle information. For example, demographic information such as ID, age, gender, country, consumptions such as coffee intake, caffeine, of weight, sleep such as sleep duration, sleep quality, vitals such as BMI, heart rate, lifestyle such as stress level, physical activity, smoking, alcohol, and occupation. The outcome is a health issue that it will predict. We handle missing values, encode categorical variables, and scale numerical features. These steps ensure the neural network processes input consistently and learn patterns effectively. The target variable is health issues, indicating whether a person suffers from medical conditions linked to lifestyle. This classification task allows us to model how daily choices and biological factors influence health outcomes. The features include demographic details like age, gender, and country, daily coffee intakes, coffee levels, etc. Together, this input provides the MLP with a wide set of signals to detect complex health-related issues. The multi-layer perceptron classifier, MLP, is the type of feed-forward neural network composed of an input layer, one or more hidden layers, and an output layer. Each layer transforms the data using weighted connections and nonlinear activity, enable the model to capture patterns beyond that linear model can achieve. Unlike logistic regression, the MLP can model nonlinear interactions between features, making it ideal for data where lifestyle factors and health outcomes interact in complex ways. Here, MLP learned to predict whether someone is healthy or has healthy issues by analyzing the patterns in coffee consumption, lifestyle, and sleep quality, etc. After pre-processing, we split the dataset into 80% for training and 20% for test. The MLP classifier is trained on training set, learning relationships between lifestyle inputs and health outcomes. Once trained, the model generates predictions on the test set. We evaluate the result using F1 score, which balances precision and recall. Now, let's move to our Scicom machine learning web app. I will walk with you how to use Scicom machine learning web app to implement our model. Here, let's name our classification task first, and then let's write a brief summary of our task. In the data type drop-down list, let's choose tabular since our data is in the CSV format. Now let's click this button to upload our data. After successfully uploading our data, we can see two tabs. The first is the table tab, which shows all of the columns of our dataset, and the data tab has the summary of our dataset. Now let's move to the pre-processing steps and select our target variable, which is the health issues. And then let's click machine learning algorithm, and then let's click the MLP classifier. And let's choose F1 score as our evaluation metric, and then let's click Perform. After a few seconds, we can see our F1 score is 0.87, which is close to 1, which is the perfect score. That means our model was able to accurately predict a result with our input features. And if we want to see the details about our prediction, we can scroll to the right with this bar, and the wet test is the ground truth of our dataset, and the wet predict is the predicted value. We can see the predictions are very close or almost exactly the same for each data point. Thanks for watching.